Okay. Hello, everybody.
Hello, everyone. Welcome to our most recent episode of Dome to Home. This is our last episode in the series about water. I'm 𝐀𝐜𝐭𝐢𝐯. I'm the theater manager at Fiske Planetarium, and I hope to tell you a little bit today about why we care about water in the solar system. And I'm joined by...
Yes, hello, my name is Amanda. I'm also pretty excited to talk to you guys about water in the universe in general. And yeah, hopefully you guys learned something neat, and hopefully you learned something that you didn't know before. So let's do it.
And of course, we have Emily helping us out in the chat. So if you have any questions as this program goes on, just go ahead and type those in the chat and we'll try to respond. And you can ask anything you want. But mostly what we're going to be focusing on today is why do we care about water in the solar system? And of course, we begin here at Earth, our beautiful home, what we often know as the blue marble because it has such an abundance of water. And in fact, there's a lot more to talk about for water on the Earth that we'll cover a little bit later. But I'd like to begin this episode by first reviewing that in our last few episodes, we learned that water is everywhere in the solar system, not just Earth. And we also learned how we know that it is everywhere, using different scientific methods like spectroscopy or even just looking with our eyeballs. In fact, just looking at Earth, you can see already two states of matter of water on here. You've got the ice and the oceans covering the surface. But in this episode, we're asking, why do we care about water in the solar system? Astronomers seem obsessed with talking about water wherever we go. So why is water so interesting to us? What is the hubbub all about? Well, to begin, I think we should take a look at some of the places that we visited in previous shows. And to do that, we're just going to do a brief overview by zooming out away from the Earth to look at our whole solar system.
Yeah, and we'll go ahead and throw up some of the orbits for our planets. So we've got Mercury, Venus, Earth, Mars, all the way out to Neptune. And we'll add a few special ones in there. How about we throw up our dwarf planet Ceres and
the god of cereal.
Let's look at Halley's Comet. How about that?
So all of these are pretty much all the different types of objects in the solar system. We've got our planets. We've got a dwarf planet like Ceres, which used to be just an asteroid. We've got a comet, Halley's Comet. The only thing that we can't really represent here is moons, but we'll be showing you that in a second. But the question is, where in the solar system is water? And so Amanda's thrown together this little graphic to highlight every place in the solar system that we have found water in some abundance. And you'll find that it's virtually every object. Of course, we're not really counting the sun. And Venus is remarkably dry. We find very little evidence of water there anymore. There seemed to be water on Venus in its past, but Venus is kind of the oddball here.
It didn't want to show off for us this week, or any weeks really.
Yeah, even though it's known as the twin planet, it's couldn't be more unlike Earth. Well, I guess if it was a different size, but it's always got its size. So fascinating enough, if water is everywhere, this means that whatever water is good for, we should be able to find that in all these different places in the solar system. And it's not just in the solar system. In fact, in other places of the galaxy, we can find water plenty. But for now, we're focusing on places that we think we might be able to visit with our space probes or with human exploration within our lifetime. These are places that we feel like are within reach to us. So there's lots of water everywhere, not just the Earth. So let's actually find out why it's so interesting to us by returning back to Earth. There's Amanda navigates us there. Recall that we're representing Earth with this blue line. It's known as the pale blue dot. Earth is remarkably blue. About 3/4 of its surface is covered in liquid water. in the form of our oceans, these very salty water. And then the white that we see in the ice, on the ice caps, that's of course frozen water. And then if Amanda adds the atmosphere and the clouds, we can be reminded that there is water in the form of water vapor all over Earth, all inside its atmosphere. So this means that water comes in all three states of matter on the Earth, and that's really unique. In no other place in the solar system do we see all three states of matter of water in a consistent form. Either it's too warm and there's no ice, or it's too cold and there's no water vapor. The water vapor is frozen out, or the liquid water is frozen into ice. Pretty much Earth is the only place where you can find an abundance of all three states of matter, of all three states of water. Now, water makes the perfect medium for this, because water goes through the water cycle, the hydrologic cycle. The water cycle means that as the sun heats up the water in our oceans or lakes and rivers, streams, it can heat the water up and they become water. It becomes water vapor. It evaporates. This evaporation forms clouds. These clouds then freeze and they rain out, becoming rain again. And then the cycle continues. So we can deliver water to multiple different places on Earth, and water can fill pretty much any location on Earth that you need it to be. It can end up filling in aquifers. It can be trapped underneath these ice sheets of the Arctic or the Antarctic. It can be, of course, spread aplenty in the form of the oceans. And we think we learned where water may have come from on Earth, perhaps in a previous episode, where we think that even things like asteroids and comets may have delivered a lot of this water to Earth in the past in the frozen form. But since Earth is carefully situated close enough to the sun, it's allowed this water to thaw out and become all the three different states, all at the same time. You can have all states of matter on Earth of water at the same time. So water is actually an ideal, what we call an ideal medium for lots of things to happen, for chemistry to happen, I should say. That if we're actually trying to ask, like, how do we try to develop something like life? How do we make interesting chemistry happen? If you just have a bunch of rocks sitting everywhere, there's pretty much nothing actually happening there. The rocks don't really interact with each other very much. There has to be some sort of energy involved. And so if the water was all just ice, not much would happen. But once you involve energy and it melts the ice and it becomes liquid, that water becomes a perfect medium to allow stuff to happen inside of it, because stuff can flow through it. It can sustain nutrients inside of it. The water can turn over very easily as the sun heats it up and as it moves around the Earth in giant, vast currents as it moves around the oceans. And this water also allows it to be absorbed into life, like plants. It allows it to be consumed by animals and to act kind of as like the blood flow of us. That this water is an excellent way to pretty much transport things around inside of a body, whether it's a plant body or an animal body. We need water. And so, in fact, it seems like, as far as we can tell, everything on Earth, every form of life needs water, especially plants, which chiefly get what they need from the water and from the air that can travel through the roots up inside the plant stalk, and they can re-release that water to other plants that need it. Some forms of animals can seem to last for a very long time without water. They can live in deserts and seem to go their entire lives without actually needing to drink water, but they might get it from other animals that they consume. Or they might be able to get it, siphon it out of the air. Plants really need quite a lot of water compared to some animals that can store it for long times. Of course, we know of cactus and stuff. So for virtually, it's actually for every type of life we know of, they all need water. Either as a medium, they need to get it from something to eat. Water is paramount to life. And that makes us think then, well, if we actually want to find life, we should be looking for where there is water. Now, you might think, well, does that mean that there's going to be life everywhere there's water? Well, on Earth, the answer is pretty much yes. In fact, there are these life forms called extremophiles. Extremophiles are, based off their name, you can tell they live in extreme conditions. In fact, phile means they like it. And so it's extremely like it. They like extreme conditions. And so there's extremely hot boiling lakes or nearly boiling lakes where bacteria and very simple life forms can survive inside these incredibly hot uh, lakes. Like one good example is Grand Prismatic Lake in Yellowstone. The coldest possible regions on Earth, like under ice sheets, are places where we can still find bacteria that have been suspended. Oh, here's a great picture of Grand Prismatic Lake. Actually, so about this picture, you can see the different colors here. The different colors of different types of bacteria that have learned how to survive at different temperatures. So the surface of this lake might be 180 degrees Fahrenheit, and as it goes down closer and closer to deeper to where the source of the magma is heating up this lake, deep beneath the earth, it's actually heating up this lake. At the very bottom, it's boiling temperatures, and so the different bacteria that can survive are different colors, and they're at these different layers into the lake. And so they can survive at nearly boiling temperatures. And some bacteria we know can survive boiling temperatures for a brief moment of time. Um, and so even in a place that is as hot as this, we can find life existing. And as I was mentioning, we can find life existing in places that are as cold as the Antarctic ice sheets, where there are lakes that haven't been reached for hundreds of thousands of years that seem like they have life suspended in them, that there's perhaps ancient bacteria, ancient forms of life in there that have managed to suspend themselves and wait for a time when it might be more hospitable for them to thrive.
Talk about your nice hot springs soaking.
I know I could not live in one of those lakes. I need just a nice cup of water. Just this.
Yes. The liquid water is one of my favorites too.
It's my favorite drink. I'm addicted to it. I have to drink it every day. But we see if you actually look even in the forms of between frozen water, extremely hot water, and even in places like in the middle of space, on the hulls of spacecraft, we have found that there's life that has survived there, and that they've managed to eke out a way to just hibernate until you can bring them back to life, say inside of a medium of water. And so even in some of the most extreme conditions on Earth, we can find that life can make a stand, and a lot of that can rely on the way that they evolved. We think that life might have began or might have even evolved in water. In an early Earth, billions of years ago, we think deep beneath the ocean, there might have been hydrothermal vent systems, tube worms, basic life forms that we know about today that can exist off of these energy sources from the core of the Earth, from the mantle of the Earth, heating them up and providing an energy source, providing nutrients deep beneath the ocean. We think that might be a place where the basic building blocks of life could get started. Or maybe some other energy source like lightning, but still within water.
And that makes a lot of sense. If, all of the life forms that we know about need water to survive, they also need these energy and these nutrients, then the perfect place for life to begin. The ocean is a great candidate. It wouldn't have to move anywhere for its source of water. And since so much of the earth is covered in water, it receives a lot of energy from the sun, and like Nick said, from those hydrothermal vents way down in the ocean. So it's a very vast place, very rich, and a great option to look for life here on the earth and maybe other places.
I mean, I like to think that the Earth is so enormous and there's so much water on it that you would think that it is like an enormous laboratory, because the entire planet is then doing chemistry inside this water. That there's so many different types of energy sources, so many different types of nutrients welling up from the inside of the Earth, or even coming from outside of the Earth, from comets and asteroids bombarding it. That it seems almost impossible that there wouldn't be some kind of building blocks of life being formed inside the ocean through this complex chemistry given the billions of years of history that the Earth has had to do something like that. Here's a little picture of what we're talking about, is that these life forms can completely live without the sun. They can survive deep beneath the ocean based on using only the energy source coming from the Earth. So, oh, there we go. Now it's even bigger. Beautiful. These are tube worms. So I like to think that if we were actually to ask a simpler question, which is, sure, we might need water to find life, but why do we care about life itself? Why is that interesting to us? I'll come back to that question a little bit later, but it seems like we all inherently are interested in finding life in the solar system. That why is it that whenever we even find a new species discovered, we're excited to know about this new species. And when one goes extinct, we feel bad. It seems like we actually really care about life. I mean, I'm alive. We're all alive. We actually care about life in some form. So finding life in the solar system that isn't just us is really important to us.
And it's some of the bigger questions that human beings can even ask is, are we alone, and where did we come from? And any chance of finding life elsewhere in the solar system gives us just that much more amount of information to answer those questions, or maybe they're answers to questions we don't even have yet.
You know, Amanda, when I was pretty young, I didn't really understand why are we alone? It's such a big question. And it occurred to me that what if I was the only person? What if I was the only person I knew about in the entire world? The only the only person I could ever meet and ever interact with. And then I learned that all of a sudden there's one other person on the planet. That would make an enormous difference. All of a sudden, I would feel like I can talk to them. I can ask them about their experience. I can relate to them. We can learn so much, an exchange of ideas, and we can just even see what each other are like. I feel far less lonely if I know there's just one other person. Otherwise, I'd be all alone on this planet all by myself. And with life, it's the same thing. Is that for humanity, it seems like we're the only life in the universe. We're all alone on this planet. But if we learn that there's one other source of life out there, not just the Earth, all of a sudden we can relate to each other. All the same reasons still apply. It becomes so interesting to reach out to that life and learn about it and to share our experience with it. And it would probably be interested in learning about us, like we're a new species to it. Now, maybe I'm not even talking about aliens. It could even just be learning about animals or bacteria, even on other planets. But just to know that even the simplest form of life, that Earth and humanity is not alone in the vast cosmos, would make an enormous difference.
Absolutely. Absolutely. And I think it would be, everything that you just said, it would be the curiosity force that's driving people to want to learn new things. And I think, what all the stuff that we're talking about, it relates in some way. All the life, all the plants, everything, it all relates in some way, even if that way is just needing water to survive. And to just learning about something that could be completely different than what we know about, but it still needs water to survive. That's really neat because it's something that's completely new to us. It helps fuel our curiosity, but at the end of the day, it's that water that is really bringing us all together. So you can go really deep with these philosophical thoughts and what if scenarios, and it's definitely really fun to go down that rabbit hole.
Yeah, and to go down this rabbit hole, I think we actually need to go. We need to leave the Earth. We need to go further out into space. Learn
Absolutely.
a little bit more where this liquid water is, because this is where I would say if I want to find life and I want to feel like humanity is not alone, where am I looking for? Because NASA, the European Space Agency, in general, humankind's exploration of space has been centered around trying to figure out more about the cosmos, and a lot of it is about are we alone and where is the water. NASA's mission, especially for the last decade or more, has been follow the water. Can we find out where the water is? Now, we showed you all the places that we know water is in the solar system, but can we find places that have just liquid water? So some of the places are, of course, Earth. Going to immediately say that one. We don't think the moon. Moon seems too cold. There's no atmosphere. Uh, Mars is questionable because Mars is perhaps too far from the sun, not a strong enough atmosphere. Mars is a hard case to argue that there's going to be liquid water on there that we're really interested in finding life. Now, maybe underneath the surface, maybe even frozen in the ice, there may be suspended life in there. We just haven't looked. But I'm mostly thinking about moons, as we saw in previous episodes, like Europa around Jupiter, Enceladus around Saturn. And I think Amanda might have another graphic for this.
Lots of great candidates, yes.
And what's interesting is that if we found that every form of life on Earth needs water, and everywhere that there is water on Earth, there is life, besides, I guess, in some of the most extreme laboratories, then that means everywhere that we find water in the solar system, liquid water in the solar system, there should be life, right? We don't know. We actually haven't sent spacecraft there to investigate it yet. We haven't done almost anything at all to test water around our solar system for life. Even the Mars rovers on Mars haven't really even touched almost any of the ice on Mars to investigate if it has any life frozen inside of it, if it had any traces of life in it. The same thing applies for looking, in for around Europa or through the plumes of Enceladus. All these different places may have some building blocks of life or life itself inside of it. We just haven't done even the most simple tests to figure this out. So on Mars, it is becoming more interesting, and a lot of people think that Mars is a big candidate for life in the past because it had an ocean of water on it about 4 billion years ago. And as Mars evolved, it was too cold and it got blasted by the sun because it was too small. It lost its atmosphere. We don't know what happened to all of that water. We think that some of it is trapped underneath the surface in the form of ice. There might be a layer of ice, something like 6 feet beneath the surface. And we know that there are lakes underneath the surface of Mars. We know there are ice caps with a lot of frozen water there. But we're not quite sure if we're going to find life there. The entire surface has been baked and irradiated by the sun. It's going to be sterilized. But maybe inside of the frozen water, maybe inside some of the more dramatic places on Mars, we might be able to find. I think this is a highlight of the lake, right?
Yep, it sure is. And we'll go ahead and make it just a little bit bigger. So you
enhance.
Enhance, zoom and enhance.
Hey, that worked. Okay, so I see a lot of different colors here. It looks like they took a lot of different swaths of data as they were trying to stitch together an image using a lot of little pieces. So they took a lot of like flat line pictures and then tried to make this picture of what the lake would look like. And this is all beneath the surface. So we can't, what we see on the surface here is this big patch of white ice, but underneath the surface, there seems to be a reservoir of water.
And then just to take one more quick look at a subsurface map, there's a subsurface ice. I know this is a little bit wordy, but you can just go ahead and ignore all of those words. And it's just telling you a little bit where some of the heavier ice is, and just an overall general idea of where some of this, again, subsurface ice is at on Mars.
So what's interesting to me is that space probes have been landing on Mars since the 1970s, and yet not a single one of them has dug more than a few inches beneath the surface in any real capacity. InSight has drilled probes down into the surface, I believe, that goes 6 feet or more down, but nothing's really dug. So if you had just an astronaut for 15 minutes with a shovel, they could dig a deeper hole. Actually, even one scoop of dirt would get them deeper into Mars. And every single spacecraft we've ever sent to Mars, every rover, everything. And so all this continuous ice layer that they put on here, pretty much all that ice underneath the dirt, if there's life in any of that, it'd be amazing to test any of that. I could go there with my big old bulky spacesuit and a shovel and go scoop, scoop, scoop. And then I could just take a sample out of whatever is down there and maybe find life. And we haven't even tried something that simple. In fact, the very first test ever done on the surface of Mars gave a positive for life. And the second test gave a maybe. And the third test and every test since then has given a no. So it was a lot of hope for the very first test ever, and maybe the second test. And then after that, we've only found no evidence of life. But it just shows that we can be easily fooled, and we really need to do a lot more to experiment.
Yeah, maybe we're a little scared. Like we said, that's a really big question to answer. And, if you were the only person on the Earth and you had one test that could tell you if there was another person on the Earth, I think that might be a little bit of a scary test to take, but
that's right.
We should always just keep pushing for better science and more science.
Now there's another completely unrelated use, is that by looking at this ice on Mars, if we could harvest this ice, whether it's at the poles or even at the poles of the moon, we think that the permanently shadowed craters, that some of those impact craters have ice frozen inside of them that never sees the sun, that astronauts could one day harvest that ice. They could then use it to break the ice apart, we could break the water apart to its base atoms. And we could use it to live, and we could use it for energy. Because in fact, water, if you were to create an experiment like this one, like what was done in this popular YouTube series called Tested, they created what's called a hydrolysis converter. Hydrolysis is the activity of taking water, which is made up of hydrogen and oxygen, H2O. You take the hydrogen and the oxygen that makes up water, and you split it apart using electricity. And then you can harvest the hydrogen separately and the oxygen separately. And we all know we need oxygen to breathe, but we can also use that for rocket fuel. So that means that if we were to travel through using rockets to other planets or the moon or anywhere in the solar system that we can find ice, we can then use that to create rocket fuel to help us get back or to travel even further. It means we don't have to take all of it with us. And that makes traveling a lot more efficient. Imagine if you want to travel all the way across your state or across the United States, wherever you're living, and you had to use your car, but you had to take all the fuel with you when you began. You couldn't stop to refuel at any location. No gas stations allowed. That'd be very difficult. So being able to stop and getting more fuel is really important. So what you do with a machine like this is that you fill it with water. You would then charge one side and the other side with a DC current, with electrical current, and then they would end up breaking apart the hydrogen and the oxygen. And they were trying to capture the hydrogen here in this little orange balloon that you can see. And of course, it's pretty slow, but nonetheless, that hydrogen can be used as for fuel. You can burn it, especially if you use the oxygen with it, and you can use the oxygen for lots of different purposes too. And yeah, that process is called hydrolysis. So this makes exploration, looking for life even in the solar system, much easier. Not just are we going there to look for water where life might live in the water, we're looking for water that can help us get further. It's its own resource. And we can drink it. Who would have known? So that's all of really what I think we want to talk about with water in the solar system today before we take questions. But the main points here is that we really care about water because we care about finding life. We care about water because we care about exploring the solar system for ourselves. Just staying on Earth. Actually, I'm going to sort of quote Carl Sagan loosely, who said, "We either spend the rest of human existence on Earth, or we venture to the stars. There's no alternative. We either stay here forever, or we eventually leave." And I think that is an interesting concept. That I think that eventually humans are going to be traveling to these other planets, to the moons, throughout the solar system, and hopefully beyond. And looking for water is going to be one of the main things that we're always going to need to drink, to breathe, to breathe the oxygen that comes from the water, and also use it to maybe sustain our plants and our rockets.
And I think that's one cause that everybody can get behind, thinking that, one day your children's might be living on a different planet, and they are going to need water just like everybody needs water today. And that's why we care. We got to learn as much as we can about everything we can, wherever we can, to help us out in the future. Change is good, and the children are the future, and we start right now.
Well said. So let's see if we can take any questions. Does anybody in our chat have any questions? And while we're waiting for questions to roll in, I'm going to mention that we think that there is water elsewhere beyond our solar system. We think that we call them giant molecular clouds, giant clouds of molecules bigger than our solar system, bigger than multiple solar systems, exist out there in space that are doing basic forms of chemistry. They're making different molecules like methane and water, of course, things like this. They're forming planets and solar systems themselves, and inside here is such complex array of chemistry that some of it even could be as complicated as perfumes. So these clouds might actually have a really pleasant scent to them. We call those polycyclic aromatic hydrocarbons.
Say that 10 times fast.
Yeah, if you're looking for the buzzword of the day. Are there any life forms that don't need water or can go decades without it? That's a great question. As far as I know, every type of life has relied on some water either at the beginning of its existence, it gets it from the place it originated from, or while it is in existence, that it sustains itself with water. That while there are some bacteria, some basic single-celled organisms, or simple multi-celled organisms, those things can find a way to suspend themselves. They can survive. They can sort of go into hibernation. Then when water comes aplenty again, they will reinvigorate when they're in some sort of something that allows them to revive themselves, that they can. So it's kind of interesting to think that like maybe a sponge is really dry and brittle and you can just crack it in half if it's not doesn't have any water. But then once you add water, it more resembles the sponge you remember. And so there are basic forms of life that can kind of do that. They can dry up and they can live for very long periods of time without water, but they're not really doing any living. They're not reproducing. They're not really they're not exchanging energy anymore. It's essentially just a collection of different systems that are staying there in hibernation. Doesn't really resemble life at that point, but once it's reintroduced to water, it becomes alive again, so to speak.
And of course, you can always talk about camels. Camels can survive up to 7 months without water. And I pretty recently listened to a podcast about it, so my useless knowledge is coming into play here, that camels actually don't store water in their bodies at all. They can drink a lot of water up to one sitting, and so it was thought for a long time that maybe they stored it, but they indeed do not. They don't have a place to store water, but they can live about 7 months without it. So that's pretty impressive for a camel.
They're storing it in fat though, right?
They do. Their humps have the fat in them. They can store some water in it, but they mostly store just the fat
for energy.
For energy, yeah.
Yeah, interesting. And I was thinking of another example. Oh, actually, I was thinking of what if there are types of life that don't live off of water. So that's a question that's been a very interesting question for science fiction writers for a long time. Is why don't we actually imagine something that can live off of, say, methane? Because if you could make methane or ethane gas into a liquid, as we see in Titan. So Titan has lakes of this type of gas, and it behaves like a liquid. It's extremely cold, and there's very little energy then inside these lakes. So difficult to have any complex chemistry in there, but it is still kind of liquid. So does that mean that we could have a methane-based chemistry that allows some sort of form of life to come about? Are there other types of liquids that we don't know about yet that can allow us to have, instead of a water-based life form, so to speak, we can have instead of a methane-based, maybe something more complicated. It's hard to really imagine what that would look like. Some scientists have said silicone-based, but I don't know of any type of liquid silicone medium. Here's some pictures of Titan's lakes here. The dark patches you're seeing here are the lakes of methane. So having an actual methane cycle means that there is some complex chemistry. There's something happening on this moon.
Yeah, and just like another little note on what Nick was saying. If another life form was using a different liquid as its like base necessity, I would feel like its chemistry and its structure, its DNA structure would probably be really different. And then it would just be a whole new deal to where we'd have to learn about this whole different type of structure of chemistry, and maybe we'll have a whole new field about like exochemistry someday or something.
Amanda, you're absolutely right. It's interesting that when we learned about regular matter, all of physics, everything we've done for all of humankind has been about learning about regular matter, about the things in my hand and this table or the chair I'm sitting in, the air I'm breathing, even the plasma and lightning we can learn about. And then we, of course, learned about dark matter, this sort of enigmatic, mysterious, extra form of matter that is strewn throughout galaxies and throughout vast regions of the universe. And it's 6 times more abundant than the stuff that makes up you and me and makes up the stuff on the Earth. So dark matter is kind of like that equivalent, is that we think it exists, we think it interacts through gravity, and it's kind of like a form of matter, but we don't know almost anything about it. And so all of biology that we know about is based on our basic elements of hydrogen, nitrogen, oxygen, and carbon. And that's in our DNA. Those 4 elements make up our DNA, and we see that 2 of those elements in water, the hydrogen, oxygen, and water. So they're so similar that what if we had something that wasn't even based on those really simple elements, or included some 5th element? So that is that's a really interesting take. Is exobiology might allow us to really explore the depths of how water can, of how life can form. But right now, we think it's completely a game of finding the water. And if we find water, we might find life. Or if we find life, we might know if we're alone in the universe or not. And either would be very scary
And
or
then
very comforting.
I guess as just like one last little push for Fiske Planetarium is, I think the biggest takeaway from this is that water, it doesn't always have to be in liquid form. First of all, there's 3 types of phases that water can be in, and we see water everywhere in the solar system, not just on Earth. Just because Earth is the only place with an abundance of liquid water doesn't mean we're the only place with any water. So we're at the end of our water series. Hopefully you've seen a bunch of cool places that have water on them, maybe in the form of ice, maybe in the form of dried up lake beds, who knows. But go do some of your own research and learn about some of this water on these other planets if we didn't cover any of your questions. Now, how thick is this ice? What kind of ice? What even is water? If we missed any questions, be sure to let us know. We love talking about it. And there is, again, a lot of water in the solar system.
It's really easy to do research, just like this. Just keep doing research every day. All right. Thank you all for joining us on this episode of Joan to Home. And thank you for Emily for running our chat, Amanda for providing us these amazing visuals. We hope to see you in our future presentations, which we're going to be doing in April 7th will be our planet from space, the most studied planet. And that should be, about Earth and a little bit about how we have come to study Earth in such great detail. Most people don't really recognize that Earth is, in fact, the most studied object in all of space. And we're going to sort of remember that. We're going to highlight that, and that's where our series will be going for April. It's our planet from space, and especially it's going to be in homage to Earth Day.
Yes. Cool. So stay hydrated.
Thank you.